Hello everyone, my topic name is algorithm for drawing lines, circle, ellipse. Today I am going to explain line drawing algorithms, circle drawing algorithms and ellipse drawing algorithm. Now we are starting with the line drawing algorithms. Algorithm overview. Bresenham line algorithm is a fundamental line drawing algorithm used in computer graphics to determine the points of a raster that should be selected to form a straight line between two points. Efficiency and accuracy. Unlike other algorithms, Bresenham algorithm uses integer arithmetic and is efficient in rendering lines with the minimal computational resources while maintaining accuracy. Applications. This algorithm is widely used in computer graphics for drawing lines and on pixel-based display and are essential for rendering shapes and images. Line drawing algorithm steps. Input. The algorithm requires 2 points x1, y1 and x2, y2 to draw a line between them. Calculate the slope m. Determine the slope of the using the formula m is equal to y2 minus y1 divided by x2 minus x1. Decided on the number of steps. The number of steps required to draw the line determined by the difference between the x coordinates or the y coordinates. Whichever has the greater difference, let's call this value steps. Calculate increment. Increment value for x and r calculate as a increment x is equal to x2 minus x1 steps. Increment y equal to y2 minus y1. Initialize drawing. Start drawing from the first point x1 and y1. Loop through steps. For each step from 1 to steps, update the current coordinates. X is equal to x plus increment and y is equal to y plus increment. Round off the coordinates. The nearest integer since x is equal to round of x and y is equal to round of y. Plot the pixel at the calculated xy coordinates. The the line drawing process completes once all the steps are executed. Line drawing algorithm comparison. Advantages over algorithm 1. Eliminates multiplication. Improves speed. Disadvantages. Round of error builds up. Get pixel drift. Rounding and floating point arithmetic still time consuming. Work well only for m is less than 1 and m need to loop in y for m is greater than 1. Need to handle special cases. Circle drawing algorithm. In circle drawing algorithm steps, the algorithm requires the center of the circle xc and its radius is r. Initialization. Set the initial values x and y coordinates to O and the decision parameter p to 1 minus r. Plot the first point. Plot xc yc plus r to start drawing the circle. Iteration process. Starting from the top of the circle, calculate the points in the other octants using symmetry. The algorithm proceeds as follows. For each step k from O to R, do the following. If p is less than 0, increment x and update the decision parameter p as p equal to p plus 2x plus 1. If p is greater than and equal to 0, increment both x and y and update the decision parameter p as p is equal to p plus 2 in bracket x minus y plus 1. Repeat this process until x is less than equal to y. Plotting points. For each step, plot the points symmetrically in all octants of the circle using the center xc. Completing the circle. Once all points are plotted for the first octant where x is less than equal to y, the circle complete due to its symmetry. Plot the points in the remaining octants using symmetry. Advantages: efficient integer arithmetic, symmetry exploitation, accurate circle approximation. Disadvantages: limited applicability beyond circle, pixelation issues, and potential round of errors. Now, ellipse drawing algorithm. Ellipse drawing algorithm steps. The algorithm requires the center of the ellipse xc, yc, semi-major axis A and semi-major axis B. Initialization. Set the initial values x and y coordinates to O. Calculate the initial decision parameter P1 as P1 is equal to B2 minus A2 into B plus 1 for A2. Plotting points in region 1. Starting from the top of the ellipse, calculate the points in the first quadrant using symmetry. The algorithm proceeds as follows. For each step, xk increment x and update the decision parameter p1 as a p1 equal to p1 plus 2 into b2 xk plus 1 plus b. If p1 is greater than 0, decrement y and update the decision parameter p1 as p1 equal to p1 minus 2 into a2 into yk plus a2. Plot the point x and y in the first quadrant. Plotting point in this region 2. Calculate the points in the second quadrant using symmetry with respect to the y-axis. Plotting point in region 3 and 4. Reflect the points obtained in region 1 and 2 across the other quadrants using symmetry with respect to the coordinates axis and the center of the ellipse. Completing the ellipse. Once all points are plotted in the four quadrants, the ellipse is complete. And the last step, the ellipse drawing process complete once all required points are plotted. Advantages: efficient integer arithmetic utilizes symmetry, accurate ellipse approximation. Disadvantages: limited access, aligned ellipse and pixelation issues. And third one is potential round of errors. Thank you.